Okay, I've been working on this for a couple of minutes and some of you have written out two equations and some haven't. Some are kind of stumped maybe. So if you plug the coordinates of this point in here, you get an equation for A and B. If you plug the coordinates of this point in, you get an equation for A and B. And two equations for the two unknowns A and B. You solve them, find A and B. Okay, let me have the process down, but some of you do know what to do, maybe got a little hung up in some of the details. And if you don't know what to do, well, I'm going to show you, but this is important stuff. You can guarantee that you're going to have to do something like this, maybe with a logarithmic function like you did for homework. Okay. So we have y equals a b to the t. We're given that this is our function and these are 2 points on the function. So the points are 3, 5, and 7, 12. Plural. Okay. And y equals a b to the t. So, and again, I recommend that you write these things out logically so that you're repeating the thought process that you're going to need to be able to recall when you run into these equations in the future. Okay. So the logic of this is we have this, and here's our equation. It follows immediately that 5 equals a b to the third, and 12 equals a b to the seventh. Okay. Now my handwriting is the greatest. If you happen to misread the coordinates, one of these points, it's no big deal. I can handle that. Okay, let's try to get it right. Okay, so what do we do? I'm going to solve the first equation for A or B. Okay. And I'm going to substitute into the second. And I'll say et cetera, because the rest, if you're doing a few of these, should follow very easily. Okay. I'm not necessarily saying it'll be easy to solve, but it should be easy to see what you need to solve. Okay. And if you practice this a little bit, you can easily do it. Okay. So first equation. 5 equals AB to the third. So A is 5 divided by B to the third. Of course, we're dividing both sides by B to the third, and I'm not going to be including those steps at this point. You have to know your algebra well enough to know that you can get A if you divide both sides by B to the third. You should still probably write that step out because you want to be very secure with your algebra if you go on into a subsequent course. Okay. So that's done. We solve the first equation for A. Twelve equals A b to the seventh becomes 12 equals 5 over B cubed times B to the seventh. which is b to the 7th over b cubed. And people are still not as secure with the rules for exponents as most of you still need to think through the laws of exponents, okay? And it's good to think through, even if you know them. You want to reinforce it so you remember it for a long time. This means b times b times b times b times b times b times b. That's the numerator. The denominator is b times b times b. You can match up those three with three of these, and you're left with b to the 4th. Of course, the rule is you subtract the exponents. That's why you subtract the exponents. Okay? You match up 3 of the 7, and they go away, leaving you with 7 minus 3, which is 4. So you get 12 equals 5b to the 4th. Leave myself enough room. Well, got this far. It should have on the screen here. Okay. So you got 12 equals 5b to the 4th. What do you do with that? You divide both sides by 5, and you get b to the 4th equals 12 fifths. How do you solve that? I'm going to stick with the laws of exponents rather than radicals, because I always work, but you should be able to do radicals as well. So you might want to review that if you're not sure. And I'm going to simply say b to the 4th to the 1/4 is the same as 12 fifths to the 1/4. So b to the 4 times 1/4 equals 12 fifths to the 1/4. Now 12 fifths is about 2.4. If you square 1.1, you get 1.21. You square that, you get 1.44. So 1.1 to the 4th is about 1.4, where you need to get 2.4. Okay. If you square 1.2, you get 1.44. And if you square that, you get about 2. So you're getting up close to 2.4. So I'm going to say, I'm just going to estimate. Of course, you don't need to estimate. You can punch that into your calculator easily enough. I'm just telling you that this is going to come out somewhere around maybe 1.22. A little question mark there. I'm not sure about that estimate. Okay. That's my best guess. Could be 1.23. I think it's more than 1.21. Anyhow, this tells you that b to the 1 is approximately 1.22. And I'm doing the step 4 times 1/4 gives you 1, just to make sure we understand. Okay. How the rules of exponents are used here. All right, well, we've got b is approximately equal to 1.22. Now, a equals 5 over b cubed. Okay. Which is approximately 5 over 1.22 cubed. And I'm thinking 1 over 1.22 cubed. About 1.8. So I'm going to say a approximately equals 2.7. Okay. Yeah, if you use your calculator, you're gonna get something more accurate. I could be off by a couple of tenths. I could be off by more than that if I'm not thinking very well. Okay? You tell me I was way off, right?
No, you're.
Okay. I'm always right. Well, no, that's not so. Okay. Okay, so y equals f of x equals 2.7 times 1.22 raised to the t. I think that should be legible. And now we have our function and we can find f of 5 and we can solve f of x equals 10. Okay? So f of 5 7 times 1.22 raised to the t. So f of 5 is 2.7 times 1.22 to the fifth. And 1.22 to the fifth, 1.22 to the fourth is 2.4. Then 20% of 2.4 is about 0.5. It's going to be about 2.9, maybe even 3. Because any errors that I make in my mental calculations are going to start accumulating. Okay? So don't expect me to be totally right any of these. That's about 7.8. And that couldn't be. F of 5 can't be. Now, I don't know what I'm thinking. Yeah, something's wrong. Because f of 7 would be bigger than I think it's going to be. So I don't want to work out the arithmetic at length here, but let me just pause for a second. See if I can fix that. I just rechecked my calculations with my limited working memory. And they still check out. I was looking at the graph wrong. Okay. This wasn't going to fit the graph, but this fits the graph just fine. Okay. So f of 5 should be 7.8. Does that make sense in terms of this graph? Well, what's the graph look like? It's got to be asymptotic to the negative x-axis, but it's got to go through these points, right? It's going to look something like maybe this. Okay. And of course, you can always sketch an accurate, reasonably accurate exponential curve, can't you? Okay. And you could use that as a basis for making estimates. So if x is 5, which is halfway between 5 and 12, y approximately equals what? Well, it's not halfway between 5 and 12 because the way this curve dips down, halfway between 5 and 12 would be 8.5. I'm going to say that y should be about 8 because it isn't that far below the midpoint. Okay. Now, does that check out this? And do you understand why it's good to be able to sketch that graph and make a reasonable estimate and see if your result is reasonable? Well, what confused me was I looked at the graph cross-eyed or something. Okay. I should have gone ahead and drawn the curve and done the estimate instead of questioning my calculation. Okay. And of course, I don't think that's exactly accurate. I think it's probably maybe within 2 or 3 tenths, but it's something like that. Might be a little lower. Okay. So do you understand the process? If you're given 2 points, you can find the exponential function for those 2 points. Okay. And the reason we're doing this is you have to do a lot of that in your homework. Okay. Had a lot of problems, applications of exponential functions. Okay. There's just going to be that one assignment between now and Tuesday. Okay. This is the process. You get the 2 simultaneous equations. I recommend you write out the logic of what you're doing at every step, at least the first 5 or 6 times you do it. After that, make sure you're not looking back to see how it's done. Make sure you're doing second half of the problem set by pulling it out of your memory. Okay. And if you can't, well, keep writing it out and then try the next problem. Okay. Without looking at it. That's how you prepare this. And I guarantee you that this, in one way or another, is going to be in the exam. Okay. So kind of giving away an example. One of the most important things. Okay. Well, there's more. We want to solve f of x. Well, what did I say, 10? Now, let's go ahead and start with an estimate. Okay. Here's 12, here's 5, where's 10? Well, here's 8, here's 12. So 10 ought to be about halfway between. And if we estimate the x coordinate, it looks like it's about 6, doesn't it? Okay. And y'all are good at estimates. I mean, as a whole, I think everybody in here is pretty good with this. All right. So rely on the estimates to guide you as to what your solution ought to like. It's not going to do the algebra for you. And of course, it's going to be an estimate, whereas the algebra will give you an accurate solution. Okay, f of x equals 10. F of x is 2.7. That's 1.22 to the t. And I said f of x, and I said it's a function of t. So let's change our x's to t's here so I can be consistent with my notation. Hopefully that didn't confuse anyone. Okay, so we have 2.7 times 1.22 to the t equals 10. Well, 2.5 into 10 is 4. 3 into 10 is 3 1/3. So between 3 1/3 and 4, maybe a little closer to the 4, we get maybe 3.7. I'll write it out. 10 over 2.7, 1.22 to the t equals approximately. Let's have it be that big. It'll be 3.6, but we'll go 3.6. Okay. Now, how do we solve this? Well, that's our old friend, just plain old exponential equation. We get that estimate, not like estimate. Um, Bill. 1.22 to the 3.6. And 1.22 cubed, we figured about 1.8, 1.22 to the fourth is, the working memory's failing me, about should be about 2.4. So that should be not coming out real well. Probably because my brain's not working. He's going to come out around 6, but 1.22 to 3.6 is nowhere near 6. I just stop and think again. Sorry. Okay, I'll go back to this again, but something's wrong with my mental calculations. Um, push it down correctly means that t equals 10. Should be 10. Divide by, and you get 3.6. And that makes a certain amount of sense. Okay, I've got to write down these equations. I keep looking at them wrong. Um, A, B, C, B, the C equals A, because it's like, you know how to solve that equation. Okay. Did I turn it around wrong? I don't think so. We're going to leave it at this. There's the equation. You know how to solve that equation. So solve it. Then somebody tell me what I did wrong. Want to move. Okay. We're going to leave that, as I said, I think it was recorded. Solve that last equation. Tell me what I did wrong. Typical problem. You have 60 milligrams antibiotic body. At noon. That's an easy one. Actually, it's maybe not easy. Anyhow, the half-life is how long do you have only 10 milligrams? Now, can you estimate that? Let's say time is noon, and we're gonna call that 0. Okay. Can you put a point on the graph? Well, at noon, you have 60 milligrams of antibiotic. Well, let's label the axes, time in hours. Amount in milligrams. And we'll call that Y. So at noon, you have 60 milligrams. So you have this point here is 0.60. Okay. Now, given that the half-life is 8 hours, can you put another point on the graph? See if you can do that. I'm going to give you just a minute or two. See if you can quickly, write down a graph and show me a second point. Okay, well, the half-life is 8 hours. What's that mean? It means after 8 hours, you got half as much. So you could put date line here, and you cut this in half, and you've got a point. This is the line. Of course, this is a line y equals 60. This is a line y equals 30. Okay. Now, can you draw a graph with a couple more points on it? Okay, well, the second point, you got 30 milligrams. T equals 8. 8 hours later, you're going to have half of that. And T equals 16 now. You're going to be at y equals 15. You're going to be at this point. Does this remind you of anything? Well, you're starting at the top and you're going halfway to the t-axis, right? Just like what you do, just like what we did at the very beginning of the course. when we construct the graph of the toolkit exponential function. Okay. And we're going by the same distance here. Okay. In other words, these lines are equally spaced because your half-life is consistent. So our first graph of the exponential function was a graph of half-life, basically. And that's the most fundamental characteristic of exponential functions. Especially includes the fact that the derivative is equal to the value. Well, if we've got 15.5, we have 7.5. Okay. So here we have a graph of decreasing exponential function. It looks just like the curve of our toolkit exponential function, except it's flipped about a vertical axis, right? So can we estimate how long it's going to be until we have only 10 units? Well, to do that estimate, we draw the line y equals 10. And we project down from the intersection point, and we see it's between 16 and 24, somewhat closer to 24. Maybe t equals 19, 1921. Right there without the smudge. Approximately equal to 21. Well, now we have an idea. First of all, maybe a better idea of what we mean by half-life, because we can relate it to constructions that we've been doing all semester. And the flip side of half-life, of course, is doubling time. If we have an increasing exponential, then we'd have doubling times, right? Okay. Well, this is all good, except how do we determine the function? Okay, so now a b to the t. Points are 0, 60. And we could use any one of these points. We'll just go ahead and use 8, 30. So 60 equals a times b to the 0. 60 equals a times 1. So a is 60. Unlike the example we started with, we've already got the value of a. It's the example we started with, the values of a and b were kind of mixed up. But here we've got a equals 60. Okay. So we can use the points 8, 30, but we already know a. So 30 equals 60 times b to the t. And then not times b to the t, it's times b to the 8th. So b to the 8th equals 60 over 30 over 60, which is 1/2. Unfortunately, I don't have room to write that when I was going. So we get B equals 1/2 to the 1/8 power. Now, what's the 1/8 power of 2? Well, the 1/2 power is about 1.4. So the 1/4 power is about 1.19. I'd say about pretty close to 1.1. Is that right? Yeah. Now, if I do 1.1, I get a little more than 2. But I'm going to still say he's about 1.1. Okay, might be 1.096 or something like that. I think it probably rounds off to 1.1. And of course, you can do 1/2 to the 1/8. Tell me if my mind is working against. Anybody do that? It's okay. We're going to do it. Okay, so now model is y equals 60 times 1.1 raised to the t. Now, how do we determine how long it is till you have only 10 milligrams? Solve 10 equals 60 times 1.1 to the t, which means you would have 1.1 to the t equals 1/6. I'm at it, let's fix this. And let's just completely turn it off there. I mean, this is an exponential equation, right? And so is this. How do you solve an exponential equation? You change it to logarithmic form. So I think my mind got so full of doing calculations that I forgot where I was or what I was. Okay, that was ridiculous. So t equals log base 1.22 of 3.6. In this case, and that would equal log of 3.6 over log of 1.22. And I'm going to say that's probably kind of close to 8. Sorry, it's kind of close to 6. And I didn't do that by calculating it. I did that from the graph because I don't think I'm going to be any more accurate than that if I try to calculate this, then plug it. Okay. It strained my working memory to the point where I don't remember where the board is apparently. Okay. So you can complete that. Somebody should have told me that. I think so. So anyhow, in this case, we get t equals log base 1.1 sixth which is a log of 1/6 over the log of 1.1. Now, the log of 1/6 is the log of 1 minus the log of 6. And the log of 6 is somewhere around 0.7. But again, visualizing that in log of 1.1 is even tougher. And that should be pretty close to our estimate if we made a good estimate. But of course, we punch that into the calculator and see if everything is as it should be. Both these logs will be negative. When you divide them, we get a positive. Sometimes you want to find the doubling time of the function that you know. For example, the function we found here, we could find the doubling time of that function in the same way we find the doubling time of this function. Okay, so we do it this way. The simplest way is t equals 0, and I guess I should use a separate t and at from the variable. Okay, at t equals 0, y equals f of 0, which is 73. 1.2 to the 0 is 1. Y would be 73. At t equals t sub dub. T sub dub. Okay. DOB stands for doubling time. Y will be 2 times 73 equals 146. So 73 times 1.2 to the t dub equals 146. Right? Now we just solve for t dub. We divide both sides by 73. And if we doubled 73 correctly, we're going to get 2. So we get 1.2 to t dub equals, oh, come on, 2. T dub equals all right, this way log to the base 1.2 of 2 as wanting to just write log 2 over log 1.2. That's log 2 over log of 1.2. So T dub approximately 3.2 or 3.3. If you plug that into your calculator, I think you'll end up with. Oh, wait a minute, 1.2, yeah, 1.2 to the fourth. 1.2 to the fourth. 1.2 cube. Yeah, it'll be in the low threes. Maybe closer to 3.2. Okay. Anyhow, understand the process. And it comes down to, in order this function to double, this part has to double, and this part doesn't matter a bit. Number out front doesn't matter, it's the base raised to the t. And let's try one more. Doubling time. Y equals f of x equals 0.079 e to the O3 t. Make sure we see that's even here. Okay. Now I'm not going to write out all the logic, although you should. Comes down to the fact that e to the 0.03 t dub would have to equal 2. In order to double, this has to double. So you can kind of shortcut the process, but I don't recommend you shortcut it until you've done the whole thing a few times. Point 0.03 times t dub equals log to the base e of 2, which is a natural log of 2. Natural log of 2 is 0.69 something. I'm just going to round it off to approximately 0.7. Of course, your calculator will give you an accurate result. Okay. So that would be the doubling time of this function. So at this point, we've seen how to get the exponential function for given 2 points, how to find doubling time. Just set the changing part of the thing equal to 2. That does it. And make sure you understand what it means. I'll comment that Then if you have this picture, now I didn't line this off very accurately. You know, all these intervals are in fact the same. The interval has length equal to the doubling time. That's obvious from the way this was constructed, and you want to be sure you understand that. So now if we wanted to graph this function, we could let t equal 0 here. T equals 23 here. Well, t equals 46 here. T equals 69 here. T equals 92 here. Down here, we let y equal 0.079. And then this line could be y equals 2 times 0.079, which would be 0.158. But instead of doing the arithmetic, I'll just write down how to calculate it. Then y equals 4 times 0.079. And here y equals 8 times 0.079. And here y equals 16 times 0.079. And if you get these numbers, you have a scale graph that shows you this function. And if you want to know when you have when the value of the function is 0.6. Okay. You look at these numbers, you figure out what 0.6 is, you can estimate how long it's going to take. And it's handy to be able to do that just to visualize how the exponential function behaves. This compounding of radar gives you whatever your principal is times e to the RT, right? Remember that? Because you need that. And then just as an example, compounded quarterly. You're adding 1/4 of the interest 4 times every year. So you cut the interest in 4 and you multiply the number of years by 4. Okay, we've been over the logic of that. And the formula, you know, if it's for compounded n times, use n instead of 4. And I recommend that you understand that rather than just memorize the formula. If you understand why the formula works, you can always write it down. If all you do is memorize a formula, you get into the exam and have the kind of brain freeze I did back there with that logarithmic equation, and you're going to be lost. Okay? Now, like I did, you might come upon a similar equation and all of a sudden it clicks, oh, duh, how could I have done that? Okay? Let's see if you can review why the formula is what it is. Okay? That's where you understand the mathematics and where you have the secure knowledge. That doesn't work. I'm sure you got good memory. Okay? I'll take it either way. All right. Again, this is a real important assignment. Don't wait until an hour before it's due to start it. Normally you'd have 2 assignments, give it plenty of time and start on it early, like days in advance, okay?